Now we're doing the domains of composite functions. And part of this problem is not composites at all. But here's the problem that a lot of students run into. They don't really know how to handle the domains of composite functions. So if that's the issue you're stuck on, zip ahead a little bit in this video towards the end. It's going to be a little longer as I go through all of these. But the first part of this video is just going to focus on these functions right here, f, 1 over g, and f over g. Okay, we'll work through those a little bit. So as you're thinking about domain restrictions, there's two sources of them. Can't divide by 0, can't square root a negative. This should be familiar from our units that we've done previously. So if I look at f of x, which is just the square root of x, I'm not dividing by anything, right? There's no fractions here, but there is a square root. So that means x cannot be negative. If x were negative, that would give you imaginary numbers, and that's not allowed. Or at least it's not allowed when we're talking about the domain of real values. So we would say x can't be negative. The way you write that is all the numbers from 0 to infinity. Okay, you can't ever reach infinity, so that has a curvy parentheses on it. But you can take the square root of 0, and that won't break anything. Square root of 0 is just 0. So there we go. Our answer to this one is pretty easy. Next one, I factored g, and then I did 1 divided by g gives you this rational function. And if you remember from these guys, you know how to deal with them when you have a divided by factor. There's no square roots, so I don't have to worry about those. But down here I have several conditions. I have x minus 5 is not allowed to be 0, meaning x cannot be 5. And I also have x plus 2 can't be 0, so x cannot be negative 2. Those are the only ways you get a divided by 0. Anything else, whether x is 3 or 5 or 70,000, well, 5 is bad, but anything except these numbers is fine. It might give you an ugly fraction, but it's a real ugly fraction. It's not some infinity. So we take our two domain restrictions, negative 2 and 5, and just wrap those together into a domain, which goes from negative infinity to the first domain restriction, which is negative 2. And then union, negative 2 to positive 5, and then union 5 to infinity. Okay, those are all the numbers that exist except for our domain restrictions. All right, next one, it's f over g. So we take the f equation, we divide it by the g equation. If you need a moment to prove this to yourself, pause the video, go back and look at it. But I'm going to make a list of domain restrictions. Up top, I know that x can't be negative, right? Not allowed, or I get imaginaries. On the bottom, I know that x can't be 5. We just talked about that one. And I know x can't be negative 2. So these are my 3 domain restrictions. Well, as you look at those, you'll realize that there's some duplication here. X can't be negative, x can't be negative 2. Do we need this one? This is not important information. I already know that x can't be negative. So when you make your domain interval for this guy, rule out all the negative numbers, right? So that's everything below 0, including negative 2, and all the other ones like negative 3, negative 4, negative 5, they're all terrible. So you start at 0, and you go to 5, which is your first domain restriction. Can't have that. Hop over 5, and you go all the way from there to infinity. Now 0 itself is okay, right? On the bottom of your equation, you'd have negative 5 times 2. That's no problem. On the top of your equation, you have square root of 0. That's also fine. So here's your domain restriction. Now we're getting into composite functions. F of g, and how do we find the domain of that? Well, this is a little bit of a nasty one. And the way you want to approach these is you look at two sources of domain restrictions. They're going to come from the inputs, or the input function, which is g of x, and they're also going to come from the output function, which is f of g of x. Those are our two sources of domain restrictions. Now the input function is this guy, g of x, and there's no divided by fractions, there's no square roots, so there's no restrictions. Okay, so we have none. No restrictions from that guy. But from the output, we are going to have some things to deal with. We have to deal with this stuff, which is the square root of a polynomial. I don't know if we've talked about this yet, but I want to remind you that it's a square root function. And at the end of the day, you can't have a negative radicand, which means x minus 5, x plus 2, right, that's g of x, cannot be negative. Now there's all sorts of things that could cause that to be negative. It's not always easy to tell just by looking at it, so I want you to graph this one. Graphing will actually be very useful in this case. -2 is one of the x-intercepts. +5 is another x-intercept. Okay, what's the function look like? Well, if you unfactor it, if you multiply this out, you get x squared minus 3x minus 10, and that is a positive even power function. Okay, if you remember what positive even end behavior means, it means I'm going up on that side and I'm going up on this side. Okay, so there's kind of what this thing looks like. Remember the original question was, where is it negative? So now using a graph, you can just easily look at all this stuff right there and say, those are my negative values. Those are all domain restrictions. It's just one giant domain restriction. So the only allowed values of x are these. X has to be less than or equal to -2. X has to be greater than or equal to 5. Remember, the zeros are okay. It's the negatives that are a problem. So the way you write that is -∞ to -2. -2 is okay. And then we're going to start at 5 and go up to infinity. Okay, that's how we do domain on this guy. Last problem. And this one actually turns out to be easier, but we're still going to look at the same two possible sources of domain restrictions. Okay, we've got our input, which is, in this case, f of x, and we have our output, which is g of f of x. Okay, and I've written those for you here. Here's the input, f of x. Here's the output, that thing. So I want two sources of domain restrictions. And as you look at f of x, this guy, what do you see? There's no fractions there. So obviously the only domain restriction is going to come from can't square root a negative. In other words, x can't be negative. Now as you look at the output function, right here, what do you see in it? There's no divided bys. Okay, there's only one square root. So that means only one possible source of domain restrictions. In other words, well, same thing. X can't be negative. They're duplicate domain restrictions. We don't need to worry about them because they say the same thing. Don't have negative values. Seriously, don't have negatives. So what that means is you simply have all the positive numbers and 0. 0 is okay.